Before we go through the process of adding and subtracting polynomials, I just want to make sure you know kind of the rough definition of what a polynomial is. So a polynomial, as shown on the screen, is an expression written in this form where the coefficients are the numbers in front of the variable, are real numbers. So all the numbers in front of the variables have to be real numbers. And then the exponents of all the variables are whole numbers. Whole numbers are any numbers starting with 0, 1, 2, 3, 4, and so on. So that seems pretty complicated, but these are perfect examples of polynomials. So you'll see there's a a real number coefficient for everything. So these are all the coefficients. This coefficient right here would be a 1, and then this is 9. So they have real number coefficients, and the exponents are all whole numbers. So these are the exponents right here of the variable. Now, when it comes to standard form, when I ask people to put polynomials into standard form, that is the correct order you're supposed to write a polynomial. The correct order is where you put the highest exponent first down to the lowest exponent. And we'll do that when we add and subtract. We'll just make sure they're in the right order. The next thing that I just want to make sure you're aware of is what's called a leading coefficient. I'm not going to ask you to name the leading coefficient, but I might use that term. A leading coefficient is the first coefficient or first number in front of the variable when you're in standard form. And like I said, I might use that term, but it's not something I'm going to ask you to identify in this context. And then the last thing here, degree. This is just something that's helpful to know. You'll hit this a lot more in Math 3 than you do this year, but I like to tell people the definition of degree. Degree is always the highest exponent of a polynomial. So the big thing you're going to really need to know definition-wise is standard form. If I ask you to put it in standard form, make sure you put it, write the polynomial where the highest exponent is first and then do the lowest exponent last. Now, like I said, these are just kind of some basics before we start doing actual problems. Today we're just going to be adding and subtracting polynomials. So a lot of those definitions aren't going to be super vital, but let's go ahead and start by adding these two polynomials. For this problem, we know we're going to be adding because there's a plus sign between the two polynomials. And the way adding works is you need to add what we call like terms. When I say a like term, so that's a really bad K, they need to have the same exponent. So for instance, on this first problem, I'm going to look at this first term. We've got a 10x squared, and the exponent is a 2. And you'll notice that this one also has the same exponent. So I'm looking at these exponents right here. So what I'm going to do is I'm going to add those two numbers together. So 10 plus 2 is 12, and then you just leave it as a x squared. So the exponent does not change when you add. So that's our first term. Then we go to the next term. We've got a 3x, and you'll notice this term over here is also x where there's no exponent. This x has a coefficient of 1, so I'm going to add those two together. So 3 plus 1 is 4, so this is going to be a 4x. And then we go to our last term. So we've got negative 10. Negative 10 has no x on it, and so does the 9. So I'm going to add those together. So negative 10 plus 9 is negative 1. And then that's your final answer. If they ask you to double check, which you always should double check that it's in standard form, remember you're just looking at the exponents, and you want your biggest exponent first, followed by the next biggest, and then you should always end with the term that has no x on it. So we are good to go. And just as a little review, if you have no exponent on an x, the exponent is a 1, just in case you didn't remember that. Okay, so that was problem number 1. Let's go ahead and do a few of those. So let's go to problem number 2. 2, we're doing the same thing. You can tell because we have this add in the middle, so we're adding the 2 polynomials together. What you're going to notice, though, for this problem is there's only one term that has an exponent of 3. Nothing else in this problem has that same exponent. So if that's the case, we're going to go ahead and write that down. So we've got 5x to the third. The nice good thing about that is 3 is our biggest exponent. So this one's the biggest, which is the one you usually want to start with if you want to just make sure that your problem immediately is written in standard form. The next biggest exponent is this 2. We've got raised to the second power, and this one is also an exponent of 2 raised to the second power. So we can go ahead and add those 2 together. So 2 plus 6 is 8. So I write an 8 and then x squared. Now this is where I usually just go to the next biggest exponent, but if you don't do that, you might just have to rewrite things in the right order. But you'll notice there's this, there's this -5 and that 3, but there's also that -7x that doesn't have a like term. There's no other term that has an x on it. So I'm just going to bring that one down just so I'm in standard form. I'll put it after the x squared. And then I'll go ahead and add the -5 with the 3. So -5 plus 3 is -2. And now I have everything in standard form because I'm going biggest exponent to lowest. So that's my final answer. Okay, let's do another one. So same idea for this problem. I'm going to look for my biggest exponent out of all of them. But we're still adding because that's what the middle piece says. So the biggest exponent for both of these is a 2. So I'm going to add those together. So we've got 2 plus, and then this is a 1. So 2 plus 1 is 3. So I write 3x squared. And then I'm going to go ahead and do the terms that have just an x. So -3x plus 3x is 0x. Because it's 0, I'm not going to write it down. So that just essentially cancels out, is what we usually say. And then we've got our 4 and our -1. So -4 plus 4 plus -1 is a +3. And then I just check to make sure I'm in standard form with the biggest exponent first, which is true. And that's my answer. Now, before I go to this problem, it might be a good idea to pause and see if you guys can do this on your own before I work through it. If you don't want to do that, that's totally fine. I'm going to go ahead and start going through this problem. So I look for my biggest exponent, which is x to the 5th. And there's no other exponent that's x to the 5th, so I'm going to write that down. So then I look for my next biggest exponent. So the next number after 5 would be 4. I don't see any that are raised to the 4th, so then I go down to 3. And I do see 1 that's raised to the 3rd. So I'm going to put that down, and that's it. So it's just plus x to the 3rd. After a 3 is a 2, so I find the ones that are, raised to the 2nd power. That's those 2, and I'm going to add those. So -3 plus 6 is a +3, and then you keep the exponent as a 2. After the exponent of 2 is just your term with just an x, which is this one right here, or x to the 1st. Because remember, this is technically to the 1st power. We just don't write it. And then we're left with our 5, so plus 5. So this problem didn't actually have a lot you needed to add. The only 2 you needed to add were the ones I highlighted in red, so the -3x squared and the 6x squared. Otherwise, it was just putting it in the correct order.